As I get more into logical circuits, computer circuits with logic gates, digital computing, I'm going to want to have handy-dandy pre-built and ready input and output boards with switches that I can hook up to just easily input ones and zeros, and then LEDs to indicate what's going on so that I can also easily film it. The biggest issue with this, though, is you don't necessarily know what voltage is coming in. It might be 5 volts, 3.3 volts, 12 volts, who knows? Which means sizing the resistors to drive the LEDs, you have to kind of choose a reasonable middle ground and hope, or put some sort of volume knob on there so that a potentiometer can change the resistance. That's silly. Also, you don't necessarily know that your signal input can drive LEDs. You may not have the power. It may be coming from some chip rather than the power supply itself. So I decided I needed to have a power supply on the board, just a USB header. I have an entire box of little solderable USB plugs that I got off Amazon for a few dollars. So I can just use a wall charger to plug in, and that'll feed the LEDs, and it'll always be 5 volts. And then the signal itself is not going to be affected in any way. It'll be just physically switched in and out. The problem is, to do this with some sort of circuitry, it's going to require transistors and all kinds of other parts. And I wanted to keep this simple and easy, so I decided to get some special switches, again for a few dollars off Amazon. And these switches allow me to operate two completely separate circuits at the same time with the same knob. So I'm going to show you me building the board in the future. But for now, I just wanted to show you the circuit connected to the switch because it's kind of cool a little bit. Each of the switches has 6 contact points, and the switch itself has 3 different positions: up, middle, and down, or left, middle, right, however you have it, but switched one way, switched another, or neutral. If you have it switched, let's say up, then these 2 pads and these 2 pads are connected together. It's physical mechanical switches, it's just a wire, there's no circuitry there, and they're not connected to each other. You've just got a path in, out, like that, and the bottom 2 are not connected. If the switch is, let's say, down, then these 2 and these 2 are connected together. So you've got a circuit like this and a circuit like this, and then these 2 are not connected. And if the switch is neutral, neither of those 2 positions, then nothing at all is connected. So it's on, off, on is what you'd call the switch. So you've got 2 completely independent circuits that you can switch together with only one single control. And you can view the middle as input or output. You can wire it up however you want. It's a physical wire, there's no polarity. So what I do is I actually have one side, the middle is the input, and the other side, the middle is the output. I don't have enough switch symbols printed out because I didn't conceive of needing 4 of them. So I'm going to cheat and use buttons. So this is going to represent the switch. If the switch is up, then these 2 buttons will be pressed. If the switch is down, these 2 buttons will be pressed, and if it's neither, then none of the buttons will be pressed. So the first thing I want to switch is the actual input signal. We're going to say A and B. Usually this is going to be high and this is going to be low. It doesn't matter, you could do anything you want. But for digital, it's going to be high and low. And then C is going to go back out to whatever. So if the user wanted, they could have C as an input. This preserves the non-polarity. They can connect it any way they want. But very simply, A goes in this button, B goes in this button. They both connect this way and go out C. So that's that side, that's done. Now we need to drive the LEDs. So we'll have our little USB charger or whatever to provide a voltage that we know. It doesn't matter what the voltage is, it just matters that it doesn't change. So conceptually, this is an output, although the user could treat it as an input if they wanted, but for digital logic, that's an output. But here, I'm going to use it on the other side as an input at the same time. I'm going to have positive power go into both contacts. I'm going to have 2 LEDs, so this being tri-state, so I can have one LED indicates it's high, one LED indicates it's low, and neither LED on indicates that that input is disabled. That's assuming A and B are high and low. They will just share a resistor because there's no reason to not, because only one will be on at the same time, which means it doesn't matter if these have different voltage drops. Here, let me hook them up. If these LEDs have different voltage drops, that means there's different amounts of current because the resistor will be the same. So you have to pick a resistor that's going to give a good brightness for both LEDs. That's not hard. And if you really, really wanted to, you could just have 2 resistors. You could have 2 resistors here and both are tied to ground if you wanted. I just don't think it's necessary. So here's how it works. So right now the switch is in the neutral position and nothing is connected to anything, so it's all just tri-state floating inputs. But let's say we have the switch up here. So the top two contacts are connected. So A is connected to C, so probably C is receiving high. And then the positive is going through this switch, through this LED, out the resistor to ground. Nothing happens here because the circuit is broken. So this LED lights up with this connection. And then, if the switch is in the other position, B is connected to C, and the positive is going out through this LED and the resistor, and that's it. So for every single bit of input that I want to have, it'll need to have one switch, one resistor, two LEDs, and then wires, of course. But that's it. No transistors, no nothing. Just one switch, two LEDs, and one resistor. And you don't even need a circuit board. None of this even needs a circuit board. You could just have the switch, and I'll show you when I build it, but you have the switch and the LEDs physically mounted to something like a thin piece of wood, and then you can just tie everything in the air. You could tie the cathodes of the LEDs together physically, and then just solder those two together with one of the legs of the resistor, maybe hot glue the resistor on or something, and then have one bus wire running through the whole thing, bringing ground to every single one. You can just stick it on the wood or the plastic or metal or whatever you're doing. Not metal, because that would be conductive. But still, nice and simple, purely physical, and separate power supply. So here's one bit, and you can scale that as much as you want. It's going to take me a little bit. Well, it always takes me a little bit to make videos, you know that. But it's going to take me a little bit longer because the planet, including my country, the United States, is currently experiencing a pandemic, a disease pandemic, which means I can't really go to the hardware store and get wood because I actually haven't checked if it's open, but also that would be stupid because I don't want to get sick. So at some unknown point in the future, if you and I are both still alive, I'll show you this board. I'm going to make an 8-bit version and see where that goes. So while you go wash your hands, and I do too, I'll be seeing you.